welcome to True Projects. In this video, we are going to explain about the project which is enhancing coronary artery disease prognosis, a novel dual class boosted decision tree strategy for robust optimization. So before getting into the execution, first let's understand what is the project about. Cardiovascular diseases, they are really big deal around the world, right? So they cause over 17 million deaths each year. And among them, coronary heart disease is the most common type. So CHD happens when cholesterol or plaque builds up in the arteries that supply blood to the heart. When that happens, it can block blood flow and lead to serious issues like heart attacks. Take, for example, someone who starts feeling chest pain or has a trouble breathing. Those symptoms can be signs of CHD, that is cardiovascular disease. But they might also point to other health problems, making it hard for doctors to figure out what's really going on. On top of that, diagnosing CHD often involves invasive tests like coronary angiography. These tests can be really expensive and common with the risk of their own. That's why catching CHD, coronary heart disease, early is so important. The sooner it is detected, the better the chances are for the effective treatment and improved outcomes of the patients. So, with the rise of electronic health records, we know how a great opportunity to improve how we predict coronary heart disease. These records give us access to a wealth of patient information, including their medical history and important risk factors like cholesterol levels, obesity, hypertension, and family history. But here the catch is analyzing all this complex medical data isn't easy. It's not like we can just look at it and make sense of it. We need advanced tools and methods to really dig into the data. Traditional clinical approaches can sometimes lead to problems like misdiagnosis or delays in treatment because they rely heavily on things like biomarkers, which can be ambiguous. This often means patients might have to go through multiple tests before getting a clear answer. So, leveraging EHRs effectively can really help streamline this process and improve patient care. So, to overcome all these challenges, in this project, we are incorporating advanced machine learning models to better predict and manage coronary artery disease. So, specifically, we are using two algorithms that are two class logistic regression and two class boosted decision tree. This idea is to really focus on the quality of the data that we are using and make sure the results are easy for doctors to understand so they can take action sooner. And here we categorize the predictions into two classes. One is class 1 and the other one is class 0. Class 1 means that the patient has coronary heart disease and class 0 means they don't. So to evaluate how well our models are doing, we have looked at several metrics, and one is accuracy, precision, recall and F1 score. So we have used all these metrics to check how well the models have performed, which balances precision and recall, and also the area under curve, which gives a sense of all the overall performance of the model. Together, these metrics helps us to gauge how effectively we are classifying cases of CHD. Moving on, to further increase the accuracy of our predictions, we have decided to use some ensemble models. So we are using ensemble method as the extension of the project. So we have used voting classifier, which is the ensemble model. So this model combines strengths of individual models. Here we are combining strengths of random forest, decision tree, and random bagging classifier. And here it turns out really well, which achieved highest accuracy. And here we're not stopping here. As an extension, we are building the front end using Flask framework. So here we are developing front end using Flask framework. This will allow users to conduct user testing and ensure everything runs smoothly. Well, also we have integrated authentication into the system, which is really important for keeping user data secure and making sure only authorized people can access it. Moving on, this is the flow of the work, which means that we have implemented the project in the following steps. So first we have imported the necessary packages, and then we have explored the dataset, that is heart disease dataset, to understand its structure and see what types of data we are dealing with. Next we have processed the data. So after exploring, we clean the data by removing unwanted columns and addressing any inconsistencies to ensure we have a reliable data set. So coming to data visualization, To gain further insights, we create visualizations like correlation matrix, which helps us to see how different features relate to one another, as well as example outcomes to get a feel for the data distribution. And coming to label encoding with data visualized, we then convert any categorical labels into numerical values through label encoding, making the data ready for analysis. The next step is splitting the data into X and Y. At this point, we define our input features to X and target variable to Y, so we know that we are predicting. The next step is feature selection. So to enhance our model performance, we are using recursive feature elimination with cross validation, that is RFECV, along with the random forest to identify and select the most significant features from the dataset. Coming to splitting the dataset, after we select the important features, we split the data into training and testing sets. This evaluates, this allows us to evaluate how well our model performs on the unseen data. Coming to building the model, now we start building our machine learning models using the selected features from the training data. Then, with the models built, we train them using a training data, allowing them to learn the underlying patterns that integrate heart disease. And then, once the models are trained, we compare the performance of the different models by evaluating metrics like accuracy, precision, recall, and F1 score and AUC to see which one performs the best. The next one we have is we compare all the models using the graphs. And then we have developed the front end using Flask framework. So we have used Flask framework to develop the front end, which will allow users to interact with our predictions. So next, in the front end, we have the dataset used. So same dataset has been used for the front end purpose. And coming to the input feature values, here user they will be giving parameters, that means inputs in the front end, and those inputs will be pre-processed at the back end, and that data will be fit with the trained machine learning model, and finally final outcome will be displayed through front end where predictions will be shown. So coming to the algorithms used, in this project we have used 5 different algorithms. One is two-class logistic function, that is logistic regression, two-class multi-layer perceptron, two-class boosted decision tree, which is the proposed one, two-class decision tree, and extension voting classifier, which is the extension model. So this extension model has performed well, so we have used that to do the prediction in the front end. Moving on, to implement this project, we have used some hardware and software requirements. So coming to hardware requirements which are needed are operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So now let's execute the project. To execute, we need to open the code folder which contains source code files. So let's open the source code folder. So now let's open the code folder. These are the source code files in the code folder of the project. Let's understand each of them, how will they be used in the project. So let's open the first folder in which we have the data set. So we have used heart disease Cleveland data set. So let's open it. It's taking a while. So this is the dataset that is used in the project to train all the machine learning models to predict the coronary disease. So these are all the independent features which impact the heart disease that we have in the target column, where 0 represents no heart disease and 1 represents heart disease. So this data will be used for training purpose. Now let's close this, get back. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is the model file. This file contains the algorithm information, and this will be loaded into the project code during runtime. This is the notebook.ipynb file. This is the Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And this file is a sample file. in which we have test cases to use it in the front end. So we'll be using all this test cases to predict the coronary heart disease in the front end. So we'll be using all these test cases. Close this. And this is the signup.db file. This file is a database file which stores the user information. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and click on enter. So the current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any other website, any other browsers. Copy the link. I prefer Google Chrome, so I'll paste it in that. So let's open the other browser. Paste the link here. Click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now let's register. So click on register link and enter all the registration related details if you are registering newly. I have already registered, so I'll directly sign in. So click on sign in. Here give the username and the password and now click on login. So we have logged in successfully and we are redirected to prediction page of the project. So here you can see the parameters, right? We need to give them as input to get the predictions. So before giving the inputs, let's understand what each parameter is. So here the first parameter, it represents the age of the patient, which is very critical factor for assessing the heart disease risk. The next one is sex, that is nothing but the gender of the person. Coming to CP, it is nothing but chest pain type. It is a categorical variable indicating the type of the chest pain experienced with the values representing different pain types that may be typical angina, atypical angina, and non-anginal pain. The next one is rest BPS, that is nothing but rest blood pressure. It is the patient's blood pressure in mmHg while at rest, which is a key indicator of cardiovascular health. Coming to that is nothing but that is cholesterol, that is serum cholesterol. It is the total serum cholesterol level in mg per dilute, providing insight into lipid profiles and cardiovascular health. The next one is talach. So what is talach? Talach is nothing but minimum heart rate achieved. It is the highest heart rate achieved during a stress test, indicating cardiovascular fitness and potential heart issues. The next one we have is exang, that is nothing but exercise induced angina. Exercise induced angina. It is a binary variable indicating whether patient is experiencing with the angina during exercise or not. Coming to old peak, it is the ST depression induced by exercise relative to rest, measured in which helps to assess the heart's response to physical stress. The next one is slope. It is the slope of the peak exercise ST segment, indicating the heart's condition during peak exertion. That may be upsloping, flat, or downsloping. CA is nothing but it is number of major vessels. It is the number of major blood vessels colored by fluoroscopy, reflecting the presence of heart disease. The last one we have is THAL. It is thalassemia. It is the categorical variable indicating thalassemia status with the values representing normal fixed defect or reversible defect contributing to heart disease assessment. So this is all about the parameters. Let's enter them. So for that, open the code folder. So we will be uploading test cases from the sample file. So here we have test cases. We'll be using them as inputs. So first, let's give the first test case. So here, age is 53. Sex is 1, which is nothing but his male. 2. CP is 2. Test PPS is 130. Cholesterol value is 246. Talach value is 173. Exang value is 0. Old peak is also 0. And next we have slope value as 0, CA is 3, thal is 1. Now click on predict. So here we got the prediction that negative, patient is not suffering from any coronary heart disease. That means patient is not having any heart diseases. Now let's give other set of inputs. So click on prediction again. So let's try with the 17th test case. So here the age would be 51, person would be male, and here the CP is 2, and here the test BPS is 110, and the next one cholesterol is 175, Talaj would be 123, exang is 0, old peak is 0.6, slope would be 0, CA would be 0, and the last one thal is 1. Now click on predict. So here we got the predictions that based on the given input, the patient has negative report. That means patient is not suffering from any coronary heart disease. Now let's try using the 25th test case. So click on prediction. Let's try with the 26th test case. So here the age would be 57 of the person, and the person is male. CP is 3, breast BPS is 165, cholesterol is 124, Talaj is 289, exang value would be 0. Sorry, Talaj is, we have entered the wrong values. So the cholesterol value is 289 and the Talaj value is 124. Exang is 0. Old peak is 1. Slope we have is 1. And the CA would be 3. Tal would be 3. Now click on predict. So here we got the prediction that patient report is positive, which means that patient is suffering from the coronary heart disease. Let's give one more set of input. So click on prediction. So let's try using 37 test case. Here the age of the person would be 35. The next one is person is male. And here we have to give the CP that is 3. Test BPS is 126. Cholesterol is 282. Talaj would be 156. And here we need to give the exang value is 1. Old peak is 0. Slope, so the slope would be 0. CA would be 0. Tal, which would be 3. Now click on predict. So here we got the prediction as positive. I mean, patient report has been considered to be positive, which means patient is suffering from the coronary heart disease. In this way, by giving inputs, we'll be getting the predictions. So now let's check with the graph. So click on graph. Here, this is a sample outcome graph where on x-axis we have the target variable and on y-axis we have the count of that particular target. So here 0, which means that a person with no heart disease, 1 means persons with the heart disease. If we look at the graph, we can observe that persons without heart disease are more than the persons with heart disease. Moving on, this is the correlation matrix which shows the correlation between the two variables. And this is the accuracy comparison graph. It is the error metric to evaluate all the classification models. So here in this project, we have used accuracy, precision, recall, and FN score as the error metrics to evaluate all the models in the project. On x-axis, we have the accuracy score, and on y-axis, we have the algorithm names. So among all the algorithms evaluated, extension, that is voting classifier is having the highest accuracy. Similarly, here we have precision comparison graph, recall comparison graph, FN score, and AUC score. So now click on logout. So in this way, by using some machine learning models, we will be able to predict the coronary heart disease in the early. By this, doctors or any other users, they'll be able to take the decisions quickly. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.